we're going to be looking at two different forms of complex numbers. We've just looked at the rectangular form, which says the real part we're going to graph on the x-axis, and the imaginary part we're going to graph on the y-axis. Now, to tell that that's imaginary, it's the one that has the I with it. Okay, but this is the rectangular form of a complex number. We want to also look at a trig form, and to develop that trig form, we need to look at the relationships among x, y, r, and theta. We have this definition for x in terms of the complex numbers. It's equal to r cosine theta. Let me show you real quick. Maybe you already recognize where that comes from, but if we take the definition of cosine theta as being x over r, that's from the beginning of our semester, and we multiply both sides by r, move it to the other side, then you can see that x is equal to r cosine theta. So that's where this definition comes from. You do something similar to that to the sine theta. Sine theta, as we know, is equal to y over r. If we multiply both sides by r, then we can see that y is equal to r sine theta, which is what we have here. The definition for r itself, it's the radius of the circle that you get when you rotate through a certain theta, through a certain angle. It's also based on the Pythagorean theorem. When you draw that triangle, when you drop that perpendicular from a point on the edge of the circle, and r is the distance from the origin to that circle, and so that gives us the hypotenuse of the right triangle. So we just use Pythagorean theorem to find r. We know that r is always positive, so we're never going to have a negative in front of the square root. The fourth thing we need is tangent. And definition of tangent theta is y over x. We're going to use this relationship to determine what our theta is. We're going to solve this for theta. So we're going to be separating the tangent from the theta, which means we're going to use tangent inverse y over x to figure out what that theta is. So these are our relationships. Now let's go look at an example where we're converting from one to the other. Now, believe it or not, people have trouble remembering which form is which, but there's an easy way to remember, because if you notice, this form here has trig in it, it has a cosine, and it has a sine. So it's in trig form because it has trig in it, and we want to convert it to rectangular form. Rectangular form is in terms of x and y, but those are usually values, and it doesn't have any trig in it at all. So if we want to get rid of the trig, what we need to do is evaluate cosine 300 and evaluate sine 300. So that's what we're going to be doing. Before we do that, I want to show you a shortcut notation, and this is notation only for writing this expression right here. These angles, 300 and 300, those are always going to be the same. It's always going to be cosine of an angle plus I sine of the same angle. Since you have that consistency in the pattern, they've come up with a shortcut for writing this, and it's this r value right here. Let me write that as r instead of 2. It's this r value, and then it's c from cosine, the I from the I, and the s from sine, and then whatever your theta is, because that theta will be the same right here and right here. So this is a shortcut notation for writing 2 cosine 300 plus I sine 300. In this particular case, we could write it as 2 cis 300, like that. It's easier to see how to evaluate it when it's in the long form, but if you're writing an answer, it's okay to write your answer 2 cis 300. So let's go back and let's actually evaluate this. The 2 is going to have to be distributed through the parentheses. There are 2 terms in the parentheses. This one is the real part. This is the imaginary part. You can tell because of the I. So we just want to evaluate cosine 300 degrees. Well, 300 degrees is all the way around here in quadrant 4. And if I go 300, then I need 60 more to get the full circle. So I have a reference angle here of 60 degrees. Use your hand trick to determine what the cosine of 60 degrees is, and you get 1/2. We're in quadrant 4, where the cosine is positive, so that's also the value for cosine 300 degrees. Okay, now we have our plus, and we have our imaginary number I, or that indication that this term is imaginary. And then we have sine 300. So hand trick again, same reference angle here of 60 degrees. But in quadrant 4, the sine value is going to be negative. So we're going to have a negative and then square root of 3 over 2. That value again from the hand trick. Now if we simplify that, we want to distribute the 2 through. 2 times 1/2 is going to be 1, and then 2 times negative square root of 3 over 2 times I is just going to change that to negative I square root of 3. So this is the rectangular form. Notice it doesn't have any trig in it. We have the real part, we have the imaginary part.